Okay, so this is the Excel template. So right now, like how it is, you can't do like anything with it, but we've already gotten a whole Excel set up for you, so you don't have to do it. Please just make sure you bring some kind of device to lab that you can download this with. I would say to go ahead and practice downloading it. Just see if you can. At least make sure at least one person in your group does have one. And we're going to click download. So wherever it downloaded to. So I'm going to open mine. So now I have it open, and this actually has formulas in it, and it's set up to autograph some things. So like you can tell right here, it's got formulas in this B7. There's a formula already in there. Oops, I don't want to change the formula. In that cell, there's a formula already in this cell right here. You can tell and keep going over. You can see more formulas. If I keep going over, there's formula there, there, and finally there. That's the natural log of the formula. So um, there's a few places like right there, there's no formula. So where you just type in data, you type in some data here, here, and here. And this is kind of where the formulas start. So when you figure out atmospheric pressure, you're going to get that from like a weather app for the area, or your instructor may even set up something that will automatically measure the pressure in the room at that moment in time. So you might be able to get from there also. You can just ask. And it needs to be in ATMs. So let's say that your vapor pressure, I'm sorry, your atmospheric pressure is like what it should be, like 1. Let's give it a little bit of extra numbers in there, but it's 1. So that's also the pressure that your air has, because that's what room pressure is. It's the air pressure. And then you're going to make the thing shrunk down smaller and smaller. So as the temperature goes down, it's going to shrink and shrink and shrink until you're really close to 0. Now, this is an experiment. So let's say we're not actually at 0 Celsius. Let's say we're at like 1 Celsius, or maybe 2. Maybe it's really close, but something it shrinks at 2, and that's the smallest you can get it. And then I'm making up a volume here. Your volume's going to be different than this. And you're going to be able to, actually measure it and all. So let's say that your volume turned out to be 2 milliliters. So you'll notice over here, it automatically calculated it. So I just wanted to point out what this is. So what it's saying is that to get in, I'm going to go over here first, actually. So PV equals nRT. So you can see PV equals nRT. Oops, it's going to try to calculate it. Just 1 second. Don't calculate it. I don't want this to be that term. I want it to be my P. There we go. Okay, so look over here. Is PV equals nRT. And if you divide both sides by RT, you get N. I've just switched the side that N is on. You could have the N on the right and the PV on the left. So you have N is equal to PV over RT. So that's what this equation is doing for the N of the air. So E3, you'll see E3 over here. That's where our air pressure is. And then over here, we need an R, that's our 8 point, I'm sorry, we need a V, which is right here beside it. So that's our F3. So it's multiplying our pressure times our volume, which is P times V. And then it's dividing it by this 0.0821, which is R. And then our temperature changed into Kelvin. The reason it's got a 1000 right here is it's also automatically converting your milliliters into liters right there. So it's like doing all the work for you, and you're getting the number of moles of air. Now, again, this isn't your number. Your number is going to be a little different. Oh, it might be around this range, or it might be even less. So we've got that. Now, when we go into our formula, what you're actually measuring every single time is the volume of the air and the temperature. And so if we're doing the volume of the air, let's say it starts off at like 5, and then it goes down to 4.8, and it goes down to 4.5, and I'm just making these up, 4.1, and we'll just make it 3.5. And now your highest temperature was 80, and then let's say that these other ones happened at like 75, 70, 65, 60, and 50. We'll just say those are what those happened at. So I totally am making up the data. You'll have data that actually looks nicer than mine does. This cell right here, it converts your temperature to the left into Kelvin by just adding 273.15. So that's cool. And I keep clicking on it when I got the formula selected. And then remember, it's actually supposed to be 1 over t. So for each of these numbers, it's doing 1 divided by it for this column. So this is actually our x column that's getting graphed, and it's set up to graph that. All right, so let me explain what's going on with both of these p's over here. So we go back over and we resolve to solve this for p equals nRT. So like this one, we divide both sides by v. We get p is equal to nRT divided by v. So right here, this one, this p, takes our n that's over here, and then our r we already know. So nr, and then our t, which is this column here, divided by our volume that we calculated, but they're converting it into liters. And so each of these pressures does that, and it does that calculation. But the reason we have this column is because we want to know what is the pressure of the water in it, not what's the pressure of the air. And so what it does is it actually is taking, like this is our air pressure, and we know that. It's like what we measured that air pressure was. And we're subtracting out the pressure of the air at the new temperature, and that leaves us with just how much water was in there. We go down, we got our water. And then this column right here gives us our natural log. It's just the ln of that number to the left. So this right here is where we convert it into water. And then you'll get your lines, and my line's a little bit off. And if yours is shown like this, the way you get to the trend line is you should be able to select, and there's a few different ways, like you might have to like tell it trend line equation. This one isn't showing me the trend line equation like I want it to. So I'm going to try to add and add the trend line like this. So did you see what I did? I grabbed a point and I right clicked, add trend line. And so here I've got some options that popped up. I want the linear, I want it automatic. I do want to display it on the chart and the R equation on the chart. So that's how I get it to do it. And then get rid of that. And there's my R. So I want to make that probably over here. And I would probably want to get that one rid of. And so these are the numbers I'll actually be doing my calculations with. So the R and the other value aren't set up to do it. You have to click on the data point, right click, and set those future features about that trend line. Also, don't forget to change your chart titles, your axis titles. Make sure you include your units, and make sure that this bottom axis is actually showing the units along the bottom too. And that should be it. Make sure that you get a graph, and make sure that your graph includes your data and your chart, your picture of it.